The James Webb Space Telescope has made a remarkable discovery. Beams of light that seem to come from an urban area millions of miles away, radiating from one location. This discovery, made many light years away, has rekindled interest in the possibility of extraterrestrial life. The telescope then shifted its focus to Proxima Centauri b, the closest exoplanet to our solar system, and discovered remarkable brilliant bursts of light. Could these emissions be the remains of an alien civilization? Stay tuned for more updates. For years, both the public and scientists alike have been captivated by the idea of life beyond Earth. Any indication of the existence of life in other parts of the universe has sparked tremendous elation. A groundbreaking moment occurred when the James Webb Space Telescope presented clear evidence implying that life could exist somewhere in space. While scanning the universe, this powerful observatory made an astonishing finding. It identified lights on a faraway exoplanet that resembled those coming from extraterrestrial cities. This sparked the possibility that an alien metropolis might exist on that distant world. The theory has generated significant enthusiasm within the scientific community, offering hope for the breakthrough they've long awaited. It points to the potential existence of civilizations and intelligent beings working in ways we are only beginning to comprehend. The lights, which resembled cities, were viewed from a considerable distance of 4 light years. NASA engineers were amazed, pondering just how long these space-based signals may have been detectable, merely waiting for our technology to become advanced enough to identify them. David Kipping, an astronomer at Columbia University, described the planet where these lights were found as uniquely complex. Unlike many rocky planets that absorb sunlight and release energy as infrared radiation, this exoplanet behaves differently due to its special relationship with its star, Proxima Centauri. This discovery, made by the James Webb Space Telescope, highlights the telescope's crucial role. Its ability to collect infrared light was key to identifying the unusual behavior of Proxima Centauri b and provided insight into the planet's atmospheric conditions. Researchers are planning to keep studying the planet's atmosphere in greater detail, hoping to determine the potential habitability of Proxima Centauri b. The James Webb Space Telescope is highly sensitive to infrared wavelengths, which allows it to observe Proxima Centauri b even at night, something many other telescopes struggle with in the vast darkness of space. Webb excels at picking up even the faintest glimmers, making it an ideal instrument for determining whether the alleged city lights on the dark side of Proxima Centauri b are real. Artificial light can be detected by a space telescope as long as it falls within a very narrow frequency range, much narrower than the light emitted by typical stars. Proxima Centauri b has a dynamic interaction with its star that significantly impacts its surroundings. Like many planets orbiting stars, it absorbs significant energies from Proxima Centauri. As the planet orbits, it experiences cycles of day and night, much like Earth. During the day, Proxima Centauri b endures intense heat, while nighttime brings much cooler temperatures. The variation in Proxima Centauri b's temperature is extreme, largely because of its composition. For example, if the planet lacks a temperature-controlled atmosphere, the contrast between day and night would be massive. One side scorching hot, the other freezing cold. Studying this dramatic temperature variation is a crucial field for astronomers, as it provides vital clues about the planet's atmospheric structure. The James Webb Space Telescope, with its aptitude for detecting infrared radiation, examines global heat emissions, offering additional information about the atmosphere's interesting properties. The telescope's orbit around Earth aligns with the orbital cycle of Proxima Centauri b, allowing scientists to closely monitor the planet. If daytime cycles occur every 11.2 Earth days and the planet has an atmosphere, the next step is to analyze its chemical makeup to determine whether it could support life. Finding elements such as water vapor, oxygen, or methane would indicate that the planet might be capable of sustaining life. While the James Webb Space Telescope is ideal for examining planetary environments, it is not particularly proficient at detecting free oxygen, a crucial indicator of life. However, it can search for other important indicators like ozone, which suggests the presence of a healthy atmosphere. As scientists analyze the data gathered by the James Webb Space Telescope, the search for distant worlds continues. This effort is bringing humanity closer to resolving the age-old question, are we alone in the universe? It's worth noting that the James Webb Space Telescope can observe only a limited number of exoplanets close to Earth. For more in-depth studies of planetary atmospheres, astronomers will rely on ground-based observatories like the Extremely Large Telescope, ELT, which is set to begin operations in 2027. The ELT is designed to provide a closer look at the atmospheric structures of distant exoplanets, offering more precise data on their potential to support life. Excitement is growing for the launch of future space telescopes, such as the ELT. In the meantime, the James Webb Space Telescope remains a valuable asset in the quest to discover life beyond Earth. For exploring distant exoplanets, despite its limitations, the Internet Telescope continues to provide important information that could dramatically alter our understanding of what exists beyond our solar system. Scientists have high goals and ambitious plans for future space telescopes. These new instruments will include techniques for reducing starlight interference, facilitating improved observations of the dim light reflected by exoplanets, much like using your hand to block the sun from your eyes. To better comprehend these distant worlds, new telescopes will block out bright starlight, making it easier to study the faint light reflected by faraway planets and analyze their atmospheres to determine whether they might support life. However, this is no simple task. Stars are extremely bright and frequently vastly outshine the planets orbiting them, making it difficult to detect the faint light that is reflected by those planets. To overcome this challenge, scientists are working on innovative methods. One such method is the coronagraph, an instrument placed inside a telescope to block out starlight while allowing the planet's light to pass through. By carefully shaping the incoming light waves, coronagraphs can significantly reduce the brightness of the star, making it easier to spot the dim light coming from exoplanets. Another promising method is the starshade, a huge flower-shaped spacecraft that flies in front of a telescope positioned thousands of kilometers away. The starshade blocks out starlight before it even enters the telescope, letting in only the light from exoplanets. This method could be particularly useful for observing planets in the habitable zone of their stars, where liquid water and potentially life might exist. These sophisticated technologies require extraordinary precision. For instance, the alignment of a starshade must be accurate to fractions of a millimeter over vast distances. Moreover, such innovations must overcome the limitations of space missions, including energy efficiency, miniaturization, and the ability to withstand the harsh conditions of space. Despite these challenges, the potential rewards are enormous. Effectively observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical signs of life, such as water vapor or oxygen in particular proportions. These molecules could indicate biological processes and suggest that life exists beyond Earth. In addition, researchers are exploring ways to directly image distant exoplanets in greater detail. Future telescopes may be equipped with advanced, adaptive optics to correct distortions caused by Earth's atmosphere or the telescope's movements, resulting in clearer images. Together with starlight blocking technologies, these improvements would allow scientists not only to detect exoplanets, but also to map their surfaces and investigate their climates. This type of imaging would represent a major leap in our ability to research exoplanets and make informed conclusions about their potential to sustain life. The development of advanced space telescopes marks a significant step forward in our search for life beyond Earth. By improving our capacity to observe far-off planets, we are getting closer to discovering whether life exists elsewhere in the universe, an answer that could drastically change our understanding of our place in the cosmos. The future of space exploration and the search for alien life is moving forward at an unprecedented pace. As scientists and astronomers delve deeper into the mysteries of distant exoplanets, the James Webb Space Telescope is ushering in a new era of cosmic discovery. The data it collects is helping astronomers uncover groundbreaking revelations about the structure and potential habitability of distant worlds. With each new piece of information, we are getting closer to answering the ultimate question: is there life beyond our planet? The discovery of Proxima Centauri b is only the beginning of what could be a pivotal moment in our exploration of extraterrestrial life.